Hi. So in this problem, we are looking at a problem about parabolas. However, we will learn a different approach to solving this problem. We'll try and solve it purely using algebra. We'll not use any of our coordinate geometry knowledge, just to show that we can do questions like this using pure algebra. So let's understand the problem first. So this says P and Q are positive numbers such that this parabola y is equal to x square minus 2px plus q has no common point with the x-axis. Then he's saying let O be the origin. Prove that there exist points A and B on the parabola such that the segment AB is parallel to the x-axis and angle AOB is equal to 90 degree if and only if this condition is true, right? So first of all, we have to prove this statement that there exist 2 points A and B on the parabola such that segment AB is parallel to x-axis. Also, angle AOB is 90 if this condition is true. So let's start from the beginning. P and Q are positive numbers such that this parabola has no common point with the x-axis. No common point with the x-axis means what? Means no intersection with x-axis, right? No intersection with x-axis. That means if you say y is equal to this was the equation of the parabola, the y will never be 0, right? This equation is never 0, right? Because if it was 0, it would intersect the x-axis. So that means this quadratic equation, this is a quadratic equation in x, this has discriminant less than 0, right? Because when a quadratic has discriminant less than 0, it has no real roots, so it will not intersect the x-axis right now, right? So if you put that condition, you will get 4p square minus 4q is less than 0, and you get p square is less than q. So first half of the condition is already solved, right? Now let's think of what we do about proving that points like this A and B can exist, right? So points like A and B can exist. So what is special about the points? They are parallel to the x-axis. So think in your mentally think about what kinds of points will be A and B. It should be like this, right? It should be parallel to the x-axis, correct? So if it is parallel to the x-axis, they will have same y coordinate, right? So if you say A is x1 y0, then B will also be x2 y0, right? B will have coordinates x2, but y0 will be same as that of A, right? So basically what we have is A and B right now are parallel to the x-axis. We also have to see the condition that angle AOB is 90 degree and A and B should lie on this parabola, right? So let me do it on the next screen. So the parabola equation is like this. And we know that A and B lie on parabola. And how have we chosen our A and B? We have chosen A as x1 y0 and we have chosen B as x2 y0 to ensure that they are parallel. AB segment is parallel to the x-axis, right? So this just tells us that we can write equations like this: y0 is equal to x1 square minus 2p x1 plus q, and y0 is equal to x2 square minus 2p x2 plus q, right? So because A and B lie on the parabola, so that means that if you had a quadratic equation like this, plus q minus y0 equal to 0, this equation has two roots, x1 and x2, right? This equation has two roots, x1 and x2, correct? So if this equation has two roots, because these x1 and x2 are satisfying this, you can see that here, right? So we can say two conditions from there. We can say discriminant should be greater than 0. And if discriminant is greater than 0, that becomes 4p square minus 4q minus y0 is greater than 0. That becomes basically p square minus q plus y0 is greater than 0, which means we get y0 is greater than q minus p square. This is the first condition that we are getting. We are also getting product of the roots, right? We are getting things like sum of the roots, product of the roots from here. So product of the roots x1, x2 is equal to q minus y0, right? We are also getting x1 plus x2 should be equal to 2p, right? We are getting this information from here. Just the fact that A and B lie on the parabola, right? Now, if you think about the final condition of the problem, which is angle AOB is equal to 90 degree, By Pythagoras theorem, that means that you should have AB square should be equal to OA square plus OB square, right? And OA square would be simply x1 square plus y0 square, and OB square is x2 square plus y0 square, and AB square is basically x1 minus x2 whole square, right? So if I apply this condition now, simplifying this, you will get minus 2x1 x2 is equal to 2y0 square. So that will become y0 square plus x1 x2 is equal to 0, right? Just simplify it yourself and you will realize this. And y0 square plus x1 x2 equal to 0 means what? Think of this condition here, x1 x2 we have already gotten q minus y0, right? So we are saying y0 square plus x1 x2 is 0 for angle AOB to be 90. We have already gotten x1 x2 is equal to q minus y0 because x1 x2 were roots of the equation because a and b lies on the curve. So we put that here, we say y0 square plus q minus y0 is 0 and y0 square minus y0 plus q equal to 0. This equation must have real roots, because otherwise your y0 will be imaginary and y0 has to be real because that was the y coordinate for both a and b, right? So if this equation has to have real roots, you can say discriminant for this is greater than equal to 0, which becomes 1 minus 4q is greater than equal to 0. Therefore, you get q is less than equal to 1 by 4. And remember, that we have already gotten earlier that p square is less than q, right? So we gotten p square is less than q earlier, and now we gotten q is less than 1 by 4. So we have proved the question, the condition that was asked in the problem, right? We have already gotten the whole proof. Now the last part of the question was asking us, can you find values of p and q for which these points a and b are uniquely determined? What do you mean by uniquely determined? If you think about a and b, x1 y0 and b was x2 y0, right? They will be uniquely determined if there are no other options, no other alternative coordinates for this. Like we should have only one value of a and b, right? It should not be like a and b can be two different sets of points, right? So if there are no other options, only one particular answer has to be there. You have to think here in this quadratic, if discriminant is equal to 0, right? You will have identical roots, right? Identical roots for y0. Right now, if discriminant is greater than 0, y0 could take multiple roots. And if y0 has multiple roots, then a and b have multiple locations possible. So it's not a unique solution, right? But if discriminant is equal to 0, y0 will have only one value, right? Only one value. And that will be a unique situation because if you know y0, you will be able to find x1 and x2, right? So what we will say here now is that discriminant should be 0, and that means q should be 1 by 4. If q is 1 by 4, we can ensure that a and b have a unique solution, right? So I just wanted to show you this question because it shows us how the algebra comes to our rescue sometimes when we have coordinate geometry problems. And you should be comfortable with combining your knowledge of algebra along with your conic sections problem, right? So this is an example where we just used theory of quadratic equations and nothing else to solve this parabola question, right? Hope you have learned something from the problem. Stay tuned for more videos. Please like and subscribe to the channel, like the videos if you like the content, and I'll see you in the next video.